Hi class, it's me. We're on day 3 of radicals, so we're finishing it up today. So hopefully you're maybe ready for this to be done because we've been dealing with a lot of radicals. So today our main goal is going to be the cube root. So if you notice, your entire paper has got the little cube in it. Okay, so you got to be really careful today when you're writing your answers. When we were dealing with the square root, so when we were dealing with like the square root of 20. There actually was a little 2 sitting there. It's just square roots are so common that we don't write that. So we kind of drop the 2. But today, when we're dealing with a cube root, we need to make sure we put that there. So it's a little number kind of inside the check. Now you can still have a coefficient out front, and obviously you'll still have a number underneath. But we're going to be looking at cubes today instead of squares. Okay, so on your note packet here, just a couple things I want you to pay attention to. It says you can extend the product and quotient properties of square roots to other radicals. So kind of what they mean is when you're going to be multiplying, actually it's on this one. When you're multiplying, the same rules apply. So see how it's a cube root and a cube root? We'll be able to multiply similar parts together. Or if we come out with something, you know, when we're adding and subtracting, if we have the same pieces, so if this is like a 2 and a 2, we can put them together. So all they're just saying is a lot of the properties that apply to square roots also apply to cubes. The other thing they say here is it says when using these properties of cube roots, the radicals may, that's the key word, may contain negative numbers. You saw a lot of the negatives on the outside in the previous 2 days, but now you'll also see some underneath. Now, you cannot take the square root. So notice I said square root of a negative number. So like the square root of -4. That is under imaginary numbers, and you don't do that till algebra 2. So see how you can't take square roots of negatives, but you can do a cube root. So the cube root, if you go under the math key, mine is the 4th option down, and then I can do, now -4 is not perfect, but we can still do it. I mean, it's just going to give us an irrational number. So notice cubes are fine, and this is kind of the reason. When you deal with a square, so let's get rid of this. When you deal with a square, you're asking yourself, what are the same numbers that multiply together to get 4? So it has to be a positive and a positive, or a negative and a negative. That's why when you take the square root of 4, you actually get plus or minus 2. We just have kind of been dropping that. Let's deal with a cube. A perfect cube would be like 8, because 8 is made up of 2 times 2 times 2. But we could also use at least 2 negatives and 1 positive. So cubes can be a little tricky when you deal with positives and negatives. Again, having taught a ton of geometry, you don't really deal a lot of negatives with cubes because imagine, you know, what a cube looks like. So just, you know, imagine a cube. You're not going to have like a negative dimension. So it's not like you're going to have a -10 or a -4. So we really don't need to worry about the negatives. I think they just kind of threw them on, you know, just a few problems here and there. So I'll deal with them, but again, don't really focus on that, okay? So perfect cubes, you probably want to list them just like we did with perfect squares. So if you want to quick generate a list, go to your y equals and type in x. And you can either go to the math key for cubed or you can do raised to the 3rd. Either one works. And then you want to go to the table. And then you just, we never are going to use 1 because 1 cubed isn't going to help us. But notice it's 8 and then 27 and then 64. So the cube root of 64 is 4 because it's 4 times 4 times 4. So it's 4 3 times. So these are like the perfect cubes. So let's just write a few of them out. So we've got 8, 27, 64, 125, 216, and 343. And then you can keep going if you want, okay? But remember, this is really 2 cubed. This is really 3 cubed, 4 cubed, and so on, okay? So if I ask you, what is the cube root of 125, you know it's going to be 5, because it had to have been 5 times 5 times 5. Now this list is kind of hard to memorize. So if I was you, or if I was your, in your shoes, I would definitely probably on my quiz, I would just generate the list and then just write them on the top of my paper. So probably don't spend your time trying to memorize these things, okay? So we're going to take the cube root of 135. Let's ignore this negative for the time being, okay? What we have to do is, just like we've been doing the last couple days, is we have to ask ourselves, what multiplies to get 135, that one of them is a perfect cube. So what you're going to do is, again, probably with your calculator, unless you really want to do this by hand, is you're going to type 135, and then you're going to pick one of these to divide in. So let's just say we start with 8. Well, 8 clearly doesn't work, so then let's try 27. Oh, look it. 27 times 5 gets me 135. Can you see my calculator? There might be like a little bit of a glare there, sorry. But you can see that it's by 5, and you should be trying this with me. So I have 27 times 5. The cube root of 27, as we saw up here, would just be 3. So the cube root of 27 is 3. The cube root of 5 is going to be irrational, so we leave that alone. Now, here's the tricky part with the negative. Where does the negative go? Does it go with the 27 or does it go with the 5? Because if I put it with the 27, so if I go like this, then I should pull this out front as -3. But if I put it with the 5, then this comes out as 3, but the negative stays with the 5. And then I got to put the little cube in there. So do you see how the negative can be kind of tricky? So are you going to put the negative on the first or on the second one? The book a lot of times just pulls it out front. So it's almost like they had it on the perfect cube and then it comes out front. But honestly, again, it's really not that big of a deal because when you guys get to geometry class, you're not even going to have a negative anyways. So it's not going to make one bit of difference, okay? All right, how about 729? So if you start with 729, try to divide some of these in. Now, yeah, this can be time consuming. I don't, necessarily disagree with you. But do you notice that it's 27 times 27? Wait a minute, that's the exact same number. This is the cube root of this is 3. The cube root of that is 3. So what I'm thinking is that 729 was a perfect cube. So see how I'm going through my list? And I'm picking the cube root of 729. That was perfect. But maybe you didn't recognize it. So if you didn't recognize it, you would go like this. You would go, okay, 27 times 27. Well, the cube root of 27, that's just 3. And the cube root of 27 is also 3. So it's like there's nothing left. We like pulled everything out. And we multiply those together. So 3 times 3 is 9. And then that would just be my answer. And I'm done, okay? So why don't you try, actually, I shouldn't even say why don't you try, because if you look, I was going to have you try the 216, but you might have noticed it, boom, it's like almost lines up perfectly. Maybe I'll have you try this one, okay? So I'll do one more. So the 216, whoa, it's right there, it's in my list, it's perfect. So notice 2, 3, 4, 5, 6. So the cube root of 216 is 6. And if you're not sure, again, you can just go to your calculator and you can type in 216 and notice you'll get 6. So the cube root, this is going to come out as a 6, so I don't have anything number-wise left over. But now variables. We've been talking about this the last couple days. So the cube root of w to the 4. Remember, you're looking now for groups of 3. So this is like 4 w's. How many groups of 3 do I have? And if I was there, I hope you're all saying 1. So see how I have one group of 3? That comes out front. This guy doesn't have a group, so he's left over. Okay? So these cube roots are the same. I mean, think about the 216. 216 is the same thing as 6 times 6 times 6. That's why it comes out of the radical as just plain old 6. Sorry. Okay, so you're looking for groups of 3 or triples instead of groups of 2 as we did in square roots. So I'm going to pull 3 out of here, but it only comes out as 1 because out of the 4, if I group it, I have one group with one left over. So then I have the cube root of W all by itself. So then that would be my answer. Okay? So why don't you guys pause it here and why don't you try number 4? So just give yourself a second. All right, hopefully you paused it and you tried this. Remember, you got to try these, okay, or you're not going to get better at it. 192, you should have been using 64 times 3. So the cube root of 64 is 4. Again, if you look up here at my chart, notice it's a 4. So pull the 4 out. Now I'm going to leave a little space for my variable, and the 3 is irrational, so it has to stay under. Z to the 5th. Again, if you think about 5 of them, I have one group of 3 here, but then I have 2 left over. So I have one group come out and 2 left over. And then that would be my final answer. So notice it's very similar to what we did with square roots, but it can be a little bit different because you're dealing with groups of 3 instead of groups of 2. Okay, so why don't you pause it here and again try 5 and 6. Feel free, work with a neighbor, help each other out. I know I'm not there, so help each other out when you can. All right, number 5. I hope you guys were productive. Let's try to make sure that we're being productive here and not just, gossiping and things like that. Okay, so number 5, just so you can quick check it, the answer is 10x to the 4 cube roots of 9x squared. That's the answer for 5. For 6, the answer, kind of a lot of variables here. It's negative 2x cubed y cubed. Then the cube root of 7y squared. So those would be the correct answers for 6 and 7, or for 5 and 6. I can't count. If you guys all feel comfortable, go ahead and kind of skip forward, but I'm going to explain 5 and 6. All right, 5, 9,000. I need to use that as 1,000 times 9. The cube root of 1,000 is 10. 9 is a perfect square. It is not a perfect cube, so I have to leave that underneath. Now again, where are you going to put the negative? On the 10 or the 3? I'm just going to put it on the 10 because that seems to be what the author of this book does. Now 14. I definitely don't want to write out 14 x's, but if you imagine 14, so you have 14 of these, okay, you have to pull out groups of 3. So if you divide this by 3, 14 divided by 3 is 4.6, repeating. That means I have 4 pairs that are going to come out, or 4 sets. So if I pull out 4 sets, 4 times 3 is 12. So I pulled 12 of these out, which means I have 2 left. So you're kind of using, I don't know, division, multiplication. You're kind of working backwards to work forwards. You kind of both. All right. So it's how many groups. So definitely go in your calculator, especially go 14 divided by the cube, and you'll notice that's your 4. And then you have some remaining. So then you just have to subtract. Okay. All right, 56. This one is actually what you guys typically were thinking of. This is 8 times 7 because 8's a perfect cube. It was not a perfect square, okay? So the cube root of 8 is 2, and then I have the 7. Now again, remember, where are you going to, the negative's on the outside, so we don't have a choice. Sorry, my eyes caught a negative. All right, x to the 9. If you divide this by 3, it's even. So x divided by 9 divided by 3 is just 3. I guess I didn't mean to say even. What I meant to say is if you have 9 of them, they pair up in groups of 3 nicely. Is that the right word? Just trying to think of the right word to say there, okay? But now think about 11. So if we go 11 divided by 3, we know there's 3 groups. So we know we're going to pull a y cubed out, but then what are we left with? Well, 3 times 3 is 9. So I pulled 9 of them out, which means I had 2 of them left, okay? So that's how you deal with the variables and the numbers. And again, it's really important to have this list. And I even sometimes still write this list on the top of my quiz test or whatever I'm doing because you forget those. They're harder. Okay, fractions. We dealt with these on Wednesday, only now we're doing the same thing with cubes. Notice at the beginning here, the bottom numbers are perfect. So these are perfect cubes, which work out nice. But when you get down to like a number 10, notice they're not so perfect anymore, okay? So when I'm dealing with this one, let's do the bottom. So the cube root of 343, we know it's perfect because we can see it. So this is 4, so this is 5, 6, 7. So the cube root of the bottom must just be a 7. But now what are you going to do with the 250? So the 250, okay, you got to think of what number you're going to use. So 250 divided by what? And again, if I was there, hopefully you're yelling out things like 8, 27, 64. It does end in a 0, so this would probably be my first choice. So I'm going to divide by 125. And I got it. So I'm going to be using 125 and 2. The cube root of 125 is 5. The cube root of 2 is irrational, so we're going to leave it alone. And then I have 7. Now remember, you're dividing by 3. So if you have 7 of them, again, if you can kind of see there's 7, I've got 1, 2 groups with 1 left over. So you're dividing by 3. So this is x squared with 1 left over. And then that would be your answer. So hopefully you're maybe feeling like these aren't too bad. What I would do on the next one, I probably would reduce this because see how there's a lot going on here? See how these are divisible and then this is divisible? It's kind of up to you. I know this is nice and clean, but I'm still going to have to deal with that one. So if I was there, I would let you guys pick, but since I'm not there, I'm just going to have to decide, and my choice would be to reduce first. So what I'm going to do is just reduce this thing down. So I've got the cube root. 16 divided by 8 is just going to be a -2. I can't do anything with the a's. And then the b's, this b is going to cancel one of these, so it's left with b squared, like that. Okay? Now, this is the trickiest piece, and this is kind of like what happens when we get to some of these other ones. In order to take the cube root, so let me just split this for you so you can kind of understand what I'm doing. In order to take the cube root of the bottom, because I can't have that radical in the bottom, I have to make this a perfect cube. So basically I have to ask myself, what should I multiply by in order to get a perfect cube on the bottom? So in the yesterday, we dealt with multiplying by the top and by this piece. But if I multiply that by b squared, let me grab a pencil here. If I multiply this by b squared like that, I'm going to get b to the 4th, which is not a perfect cube. So I don't want to use exactly what I see. What I want to use is what I'm missing. So in order to get this a perfect cube, I need one more. So let's go with the cube root of b. When I multiply those together, that's going to be the cube root of b cubed, which is just going to be plain old b. And that's what I want. So basically, I need to figure out what I'm multiplying by. So it's a little bit trickier today. So now I'm going to multiply by the cube root of b on the top. Notice I don't have any numbers to multiply, so I'm just going to recopy that. So that's just -2. The a doesn't have anybody, and then now I have a b. I do need to clean up the top. The 2 I can't do anything with the 2, so the -2 stays. Now I guess I could pull the negative out because it could be a 1, because 1 is a perfect cube, or you could leave it, it really doesn't matter. But a to the 8th. So if you think about 8 divided by 3, notice there's 2 groups of 3, but I have some left over. So I'm going to pull out a squared. 2 times 3 is 6. So if I pulled 6 out, I'm left over with 2. This b is stuck under the radical, and he's stuck there. Now, a lot of people will try to reduce these two, but you can't because this one's protected by the radical, okay? Those can be a little bit tricky. I'm not going to deny that, okay? So let me just check something here real quick. Okay, so number 9. Again, I wish I was there. I'm going to show you the alternate to this, but you are going to have to do this. So this is not a bad process because you are going to have to do this, okay? Because I'll show you one in a second where you don't have a choice. You have to go to that, all right? This one, if you actually look, we don't have it on our list there, but if you actually go the cube root of 512, notice it's perfect cube. So could I reduce 12 over 512? Could I reduce that? Yes. But if I reduce it, then I'm not going to have a perfect cube anymore. So what if I just go ahead and take it the way it is? Okay, so let's just split it. So I have the cube root of 12, a to the 6. Now we just saw that the cube root of 512 is 8. So the cube root of 512 is 8, and then 9, doesn't that mean I just have 3 pairs? But what about this 12? Is there anything I can do with 12? Do any of these numbers up here go into 12? And obviously, it's just the first one, because this is bigger than it. So you're like, nope, 12 is done. But what about that a to the 6? We could pull a few of those out, couldn't we? So the bottom is all done. So you got the bottom, done. The 12 you can't do anything with, so that's done. But the a's, if I have 6 of them, again, if I divide by 3, I have 1, 2 pairs. So a squared comes out. And then that would be my final. Now, if I reduced it, it would kind of look similar to this problem over here. So these two are kind of like two different methods. Obviously, this is way faster, but this is still a good process because you're going to have to do it here. So I'm glad that I showed you this because now you kind of already a little bit know what to expect. So on 10, we got to get this radical out of the bottom, right? I can't reduce the 7 and the 4 no matter what, plus the 7 doesn't have a radical, so it's like, okay, I can't do anything. And I can't take the cube root of 4 because it's not perfect. So what am I going to multiply by to get, a perfect cube over here? So what you should be saying to yourself is 4 is basically in a way closest to what number? Well, clearly 8. So 4 times what gets me to an 8 because I want it to be perfect. And I'm hoping you're all thinking 2 because 4 times 2 is 8. Okay, the same thing with x's. I only have 2, but I need a group of 3, so I need 1 more. So I need to multiply this by x in order to have x cubed. See, my whole goal is to create a perfect in the bottom. Now, the rule, I have to use the same number on the top. So there we go. So if I multiply the top together, this is 7 cube roots of 2x. So the top, there's not going to be much for anything for me to do because the top is kind of done. So I'm just going to recopy the top. But now we can clean up the bottom. So the square root of 8 is 2. The square root of x cubed is x. Now you can only reduce these two. You cannot go in there, even though they look the same, you can't. It's protected by this radical. So this would be my final answer. Okay? So why don't you guys try 11? Go ahead and pause it here and try 11. Let's see how you do. All right, hopefully you paused it. Number 11, if I did it right, should be 6 cube roots of 5m squared over 5m cubed. Okay? Let me show you how that's done. So if everybody's okay with that, you can move on. So actually, I'm just going to recopy it onto this other piece of paper here. I don't have a lot of room there. Okay, so there's number 11. Did you have time to check it? Sorry, I might have moved kind of fast there. When I'm by myself, I go kind of fast. All right, so I'm going to multiply. I need to get a perfect cube. So if you look, 25 is closest to 27, but there's no way that I can multiply anything by 25 Like 25 times no number is going to get me to 27. So what is the first number that I can get to from 25? And it would have to be 125. So I need this to become a 125. So it's like, what do I have to multiply 25 by? And you can either sit here and try numbers like that, or you can just divide them out and it'll tell you. So I need to divide it or multiply it by 5. So it's the cube root of 5. I need this to get to multiples of 3. So 4, notice I would have a pair of 3, I'd have 3, but then I'd have this one guy left over. So I need groups of 3. So I've got one group. So if I add one more, that's not going to be enough because now I have 2. I need to add another one. So I need to add m squared because now that will give me 6 of them, and now they'll all come out nice and clean. So if we just deal with the bottom, the square root of 125 is 5. I have 6 of them, so 6 divided by 3 would be squared. So there's my bottom. Now the top, I just have to multiply the top and bottom by the same number. Remember, you have to use the same number here. So the top, we just multiply straight across. So 6 cube roots of 5m squared, like that. And then that just comes straight down again. And so that's my answer. So these can get pretty tricky, pretty complicated. I don't want this video to be extremely long. I know it's an advisory day and things like that. So in number 12, I'm just going to tell you the answer. If you guys have got some time and you want to pause it and try it, you can. If not, we can always look at it on Friday when I come back. So the answer would be the cube root of x squared over 2x, if you want to give that a try if you've got some time. All right, number 13, we got to add. So on number 13, we have to break this down. So we got to look at this just like we would have done up on numbers 1, 2, and so on. Now notice they don't give us any variables, so it's like at least we got a break from that. So 432, okay, so if you want to grab your calculator, 432, start dividing them in. Now 8 and 54, is that what we want to use? Problem with 54 is also divisible by what, 27? Yeah, so that's the problem with that one. That's like one of those hidden ones, so I don't want to use that. So let's start with 432. Let's start a little bigger. Let's start with 64. Nope. How about, I doubt 125 is going to go. And now 432 with 216 is 2 bigs. Oh yeah, there we go, 216 and 2. So see, sometimes you're not even sure. Sometimes it's like you got to keep trying them. And even myself as a teacher, these are big numbers. I don't always know all the multiples either, but I know little techniques that help me. So I've got the cube root of 216 times 2. And again, the negative can be irrelevant. So the square root of 216 is 6. So this is coming out as a 6. And then the 2 is irrational, so I'm going to leave it alone. Now, we should probably put the negative out there, because if we want these guys to match, if we leave the negative under, then it's not going to match. So let's pull it out. I think that's why the book pulls it out, is because they're matching. All right, so there's nothing we can do with this one because he's already as low as he can go. So we've got 8 cube roots of 2. See how my radical piece is exactly the same, so now I'm just going to add my coefficients. So negative 6 plus 8 is 2 cube roots of 2. And then that would be my final. So this is kind of a combination, obviously, of what we've done with square roots and now combining with how to break it down with cubes, okay? So why don't you pause it here and try 14. Notice this is the last one with now subtraction, and then we've got multiplying. Now notice there is no foiling on these, okay? So go ahead and pause it here and try 14. All right, the correct answer to 14, I'm going to write it up here, would have been negative 3 cube roots of 4m squared. That would have been the correct answer. 108. 108 would be broken down into 27 times 4. And again, I know a lot of you think, oh, that 4. No, that 4 is a perfect square. It's not a perfect cube. So 27, this comes out as a 3, and then the 4 is left over. You know what? I'm going to leave some, oh, my variable is not going to come out, so it's fine. So the cube root of 4, and I have this coefficient out front. Now the m squared can't come out because it doesn't have enough to come out of the cube. The 4, if you noticed, is I can't do anything with, plus it's right there. So you're like, hey, I kind of wanted that to stay the same. So I'm just going to recopy this down, but I'll leave it. So I'm just going to bring this straight down. Does everybody agree that's 15? So we have 15 minus 18. That's how I got the -3. Okay? All right, the last section is the monomial times the binomial. Again, with cubes, for whatever reason, they don't give you the 2 binomials like this. I don't know why they said, hey, we'll be nice this time, but for whatever reason, this is where they stop. I did notice after I copied this, I forgot the last parenthesis on all of these, so just if you want to close those off, I apologize, okay? So just like normal, we have to distribute, only notice our numbers are going to be kind of big. So it's like 7 times 54. So this is the cube root of 378. And then we distribute again. And just like normal, it's radical times radical. So this would be 11 and then cube root of 14. Now you know 14 is not going to go any lower. It doesn't go lower as a square, not going to go lower as a cube. So you can kind of cheat by this one, okay? So I have no idea what goes into 378 with perfect cubes. But let's try 378 divided by 14 because we probably want them to match. So notice 27 is a perfect cube. So I'm going to be using 27 times 14. And then obviously this one is just going to come down. So the cube root of 27 is 3, and then I have 3 cube roots of 14. And then because the 14s are the same, we're going to add the coefficients. So 3 plus 11. And now then the radical piece stays. So I hope I'm not going too fast. It's really hard when you're sitting here by yourself not to go super fast. Also, I'm sorry that this is a little long. My goal was on this only to be 15, 20 minutes, but it's getting a little lengthy here, okay? So if you've got time, why don't you guys try 16 and 17? If you don't have time, I guess you'll have to stop it here and try the homework, and then we'll go from there. So if you've got time, go ahead and pause it. Otherwise, let me tell you what the answer is here. So 16 actually cleans up really nice into a -7 cube roots of 6. So that comes down pretty good. Number 17 actually does not come down that nice. What happens is this turns into a perfect cube. So that comes out to be just a 6. And then this one doesn't turn out to be perfect. So this one comes out to be 3 square roots of 10. So this is a little nastier that you have to break down. This one is really nice that you break down, okay? So hopefully cubes weren't too bad, okay? And the sub will put up the homework on the board. So tomorrow we're going to be covering 9-3. We kind of already talked about the order and everything like that. So we'll be covering 9-3 tomorrow. All right, have a good day and work hard.